Hello, this is Nico, and in this Science with Nico, we are going to take a look at acids and bases. Okay, so when we talk about acids and bases, we need to really nail down our definition of what an acid and what a base is. And a lot of that is because our definitions of acids and bases has changed dramatically over history. And so what I'm going to do is I'm going to introduce you to these definitions of acids and bases with the point that we'll be adding more to them as we explain how our concepts of acids and bases have changed over time, and as we actually look at some of the current theoretical understandings of the behavior of acids and bases. And those are that acids are substances that donate hydrogen ions, and bases are substances that accept hydrogen ions. Now, an example of this would be to look at hydrochloric acid. Okay. Now, in the case of hydrochloric acid, that's, in this example, reacting with sodium hydroxide, both in aqueous solution, to form water and sodium chloride. It's a classic neutralization reaction. Now, what's actually happening here, if we take the spectators out, which is what the sodium chloride actually is, because they don't actually change at all, we have our donated hydrogen ion in solution from our hydrochloric acid reacting with our sodium hydroxide ion that has gone into solution when the sodium hydroxide has ionized to form our water molecule. That's the net overall chemistry that's actually happening just there. All right. And what you need to be mindful of when talking about acids and bases is that you're most often talking about the reaction between a hydrogen ion and a hydroxide ion, and you need to keep track of those. So in keeping with that, we need to discuss some common acids and bases. All right, to start off, let's look at some common acids. Now, specifically, we have listed here hydrochloric acid with its formula listed in blue just beside it here. Sulfuric acid, nitric acid. These are probably your three most common lab acids. They're all strong acids, and they're actually they're really old in terms of being used in chemistry and more even alchemy beforehand. All right, and then of course we have the weak acids that we're going to be examining in class. In addition to those strong acids, ethanoic acid and citric acid. Okay, now in each case of these acids here, the hydrogen ions that can be donated, I'm just going to underline those. All right, so with HCl, it's pretty straightforward. You've only got the one hydrogen. With sulfuric acid, there is two hydrogen ion groups, and which can both be donated. And with nitric acid, there is again the one hydrogen ion. Now, in the case of organic acids, which is what many of our weak acids are, it's a little bit more complex. And really what you're looking for is a COOH group in most cases. Okay, so as a functional group, that's actually going to be a oxygen double bonded to a carbon, which is then bonded to an OH group. And it's that hydrogen that can be donated. So in these structures just here, there's the hydrogens just here that can be donated. All right, these are important acids for you to remember, because most of the examples we're going to do, both in these videos and in class, are going to use these acids. Now, on top of that, we also have some common bases that you need to keep track of. All right. And just to start us off with, I'm going to use a small number of bases. We will introduce more over time, but we need to be mindful of sodium hydroxide, potassium hydroxide, and calcium hydroxide. Now, each of those are strong bases, and each of those will see heavy use. All right, sodium and potassium hydroxide are just generally useful strong bases. Calcium hydroxide has some specific uses in the chemical industry as well as being a strong base. that we will get into later. All right, now in each case here, remember that with a base, we're actually after a hydroxide ion when we actually talk about the chemistry of a base and the ability to release a hydroxide ion to accept that donated hydrogen ion from the acid. And we can see here they're all fairly straightforward to identify the OH minus hydroxide ion that will actually be released from the base when it ionizes in water. Okay, now just to finish us off, we need to also take a look at some common reactions that take place between acids and bases and other substances. These are things you just need to know. All right. Now, with our common reactions, an acid plus a base, this is a classic neutralization reaction. Acid plus base gives us salt and water. And we have an example just here where we have sulfuric acid reacting with potassium hydroxide to form potassium sulfate and water. Okay. Likewise, for our second common reaction we need to be mindful of, we also have an acid plus metal gives us salt plus hydrogen gas. All right. Now, in this case here, I'm using in the example nitric acid reacting with some zinc metal to form a zinc nitrate salt and hydrogen gas. That's one you'll have encountered many times in junior high school when you have done reactions to produce hydrogen for a pop test. You're often reacting an acid with zinc metal to produce hydrogen gas, and it's the hydrogen gas that ignites to make the pop. And of course, we have an acid plus carbonate will give the salt plus water when that causes a neutralization reaction, but because the carbonate, the COO3 group just here, will also release carbon dioxide, you get quite a lot of bubbling when you have that reaction take place. And so with our example here, we have hydrochloric acid reacting with copper carbonate to form copper chloride as a salt, some water, and carbon dioxide. Okay, let's finish off just by saying that you need to be able to work with these common reactions, and I have a challenge for you to do. Now remember, with these challenges, the idea is that once we've read the question, we hit pause on the video, you give it a go at home, and then I go through the answer with you. All right, so in this challenge, for each of the examples below, just here, you need to write the products and balance the equations. Okay, and so you'll take note that each of these deals with those common style of acid and base reaction that we just talked about. All right, so just remember, hit pause, give it a go at home. Feel free to backtrack in the video and have a look at those common reactions if you need to. And when you're ready, hit play again and we'll go through the answer. All right, don't forget, hit pause. Okay, let's go through that answer. Now, in the case of our first one just here, all right, we have nitric acid reacting with sodium hydroxide. That's going to form a salt where it picks up the nitrate ion from the nitric acid and the sodium cation from the sodium hydroxide. All right, and where our donated hydrogen is going to be donated to our hydroxide ion to form water. Likewise, for our second example, where we have sulfuric acid plus calcium metal, they're going to react together to form calcium sulfate. All right, and hydrogen gas. All right, finally, we're also going to take a little note that when we have some sulfuric acid reacting with our sodium carbonate, what's going to happen here is they're going to form a salt plus water plus carbon dioxide. Okay, and the salt they'll form, we pick up the sodium from the carbonate plus your sulfate anion from your acid to form sodium sulfate. Note that there are 2 sodium ions there. All right. Just as there are 2 sodium ions in the sodium carbonate, when it comes to balancing this equation, we'll form water when the 2 hydrogen ions from the sulfuric acid pick up an oxygen out of the base and carbon dioxide. Alrighty, so that wraps us up for this video, and in quick review, we have introduced acids and bases. We've taken a look at just some basic definitions of acids and bases and looked at some common acids and bases as well as common reactions. Thank you for watching, and if you have any questions, feel free to ask in the comments below or in class. See ya. Bye.